Greetings, I'm Russ North, and in today's video I'll be showing you how to program your LEGO Mindstorms EV3 robotics kit to follow a line. The line we'll be following today is simply a piece of electrical tape taped to the floor. Once we start in our program, I've already saved this program with a special name so that I can find it easily on the brick. I'm going to close this to give me a little more palette room. The next step I need to do is to go to port view in this bottom area of the bot information. Now, if you click here and you get nothing, check here to make sure the EV3 is red, which means your brick is connected. And to be connected, it has to be plugged in using the USB cable and powered on. Some people forget that. So we click over here, we see we have the touch sensor, and over here we have the light/color sensor. All right, so first thing we want to do is find our sweet spot. And by that I mean, where do we want the robot to follow the line? With this demonstration, we're going to have it following the left edge. We don't want it right in the middle, and we don't want it all the way off. Now you'll notice that the variables are changing right now as I reposition the bot on the paper. This is on the white part, and it's reading in the 80s and 90s. Then this is directly over the electrical tape. I get a 9. But I don't want it directly over the electrical tape, so I'm going to move it a little bit over here, get it about halfway, and looks like about a 50. So we'll use 50 for our sweet spot today. So the first thing we need to do, we have our start go brick already up there, block, excuse me. We need to get our sensor. Sensors are in the yellow section. We're going to use this one, the color sensor. Slide it on up here. First thing we want to do is change that, because we don't want it to measure color. We want it to measure reflected light intensity, which is the middle selection. Okay, now we need to do something with that information, because now it's measuring it, but we have nothing to do with it. So we are going to use one of the data operations blocks. And we're going to use the ones that says math. I'm going to slide that up there. Right now it's set on addition, but we are going to need a little more complicated formula than just addition. So we're going to go to advanced. And advanced allows us to use multiple mathematical operations in one formula. The one that's default is A plus B minus C times D. We're going to change that one around a little bit. We're going to delete the D. We don't need that. We're going to put a parentheses around the A and the B, because we want that operation to happen first. And we're going to change the plus to a minus. Then we're going to change the minus C to a times C. So all we have to do is change that to multiply. Now our formula is correct. That number we took earlier, which I said our sweet spot was 50, we're going to put in our A variable. So we're going to put 50 there. All right, now for our B variable, we're going to use the measurement from the light sensor. And to do that, we grab this wire, this data wire, and we just align it with the B and line it up. So right now, we have 50 minus whatever the light sensor is times C, which is 0, which is 0. So we're going to need to change that, because we can't have a 0. If it's 0 all the time, it's not going to be very effective. So we're going to change this. Let's start with a -1. Okay. Now we're going to need some sort of movement. So we go to our action block, we go to move steering, and it really needs to be move steering, because move tank turns the robot a little differently. So we're going to use this one, and you'll notice we have an equal, or the result of our equation, data wire, and we're going to put that to our turn variable of the move block. And we're going to change the move block from on for rotations to just on. Next, we're going to change the power to 20. Make it a little easier to handle. If we get going too fast, it will cause the robot to move rather strangely. So let's look at this whole thing. the the color sensor is going to be on measuring reflected light intensity. It's going to send that information to this variable B here, which the formula is A minus B times C. Then the result of that operation is going to go here to our turn column, our turn variable in the move block. So if we have 50, and that's our sweet spot, that's where we want it to be, if it is registering 50, it will reflect that into B. So we have 50 minus 0. 0 times any number is 0, so this turn block will be 0, meaning it will go straight in the direction we want it to. If B is anything other than 50, it's either going to return a negative value. If it was 60, we would have 50 minus 60 is a negative 10, times a negative 1 would be 10, so it will turn to the right 10. And vice versa. If this was 40, it would be 10, 50 minus 40 equals 10, times negative 1 will be a negative 10 and turn it to the left. So it's going to turn it the proper direction. That's why we have a negative number in our C block as opposed to just 1. We want it to turn the correct direction. Now this, as it's set up right now, will only work once. We want it to go multiple times. So to do that, we need our loop, which is under the flow control. We grab our loop, we throw it next to our start block, then we're going to select all of these. We'll throw those inside of our loop, hopefully, somehow. There they go. And it will just keep going around and around. The light sensor will keep sensing and sending information to our math block, which will make the corrections to the steering, and it will hopefully follow the line. Let's see how it goes. So here we are testing the light sensor movement. This program has the C variable at -1. Let's see what happens. Doesn't seem to be following the line very well. And it definitely had trouble with that left turn. So we need to improve on that. Right now it's trying to locate the line again. It might take a while. Alright, so let's change variable C to something different and see if that affects how quick it responds to turning. Alright, so for our first time that wasn't too bad. The -1 wasn't quite enough turning to keep the robot in line with the lines very well. So we're going to change that variable. Let's go to a -3. We'll download that to our bot. There we go. And let's try that. Okay, so now we've changed the variable to -3. Let's start the program and see what happens. As you notice, it's a little more jerky than the -1, but it is following the line a little better. Let's see what happens with this left turn. There we go. All right, so what should happen is when it gets to the end of the line, it should circle around until it finds the line again, in theory. There it goes. And here it comes back again. And we'll continue this indefinitely until we turn off the program or the bot runs out of battery power. So there we have it. A successful line following program using the mathematics block. Okay, so that worked quite a bit better. It was able to follow the line. Not only that, when it got done, it kept searching for the line, found it again, and came back. I did not plan for it to do that, it just happened. Now there are many ways for you to program your bot to follow a line. This is just one of them. Some people like this method because it uses a very few number of blocks And then on the opposite side, some people maybe have trouble understanding this area here with the mathematical operation that goes along with it. It worked for me. I enjoyed using this program, and I think it is simple enough to understand. It uses a few scary words like advanced when it's really not that advanced. It means we get to adjust it to ourselves. So I hope you enjoyed the video. I look forward to creating more programs in the near future. Thank you for watching.